Hello and welcome to this A-level video series which is going to go through work solutions for past papers for part of the OCR physics course. The paper we're going to be doing in this video series is the June 2013 mechanics paper, which is part of the AS course. What I recommend you do is you pause the video at the beginning of each question, have a go yourself before you kind of watch the video for the work solution. Okay, so let's get started on question 1A. Okay, so this is so a student writes 4 incorrect statements shown in the table. The error in each statement is circled. Write the correct answer for the circled unit or number. One has already been done for you. So this first one's been done for you, where it says the weight, okay, of a person is about 700 kilograms. We know weight is a force, and they've said 700 kilograms, and kilograms is a measure of mass, so that's definitely wrong. And they've put the correct unit, the Newton, capital N. Okay, so let's go on to the next one. The atmosphere exerts a pressure of 1 times 10 to the 5 Newton meters squared. Okay, so they're implying that's newtons times square meters. That's not what pressure is. Okay, pressure is force over area, and if you were to write the units for that, force is newtons, area square meters are the SI units for pressure. So you can see that's newtons per square meter, not newtons times square meters. Okay, and how we normally write this, the conventional way to write this in physics, is you write it like this. Okay, this minus means that it's per square meter. Okay, writing it this way just means you don't have to write this / here all the time. You can do it's a bit neater to write it this way, which is the way you should write it, it's the conventional way. So this and this are mathematically identical. Okay, it's just this second way is a better way to write it. Okay, so it's not newtons times square meters, which is Newton meters squared, it's newtons per square meter. And that minus is very important. If you miss that minus off, you're implying pressure is Newton meters squared, which is newtons times square meters, or force times area, but it's force divided by area. Okay, so let's have a look at this next one. A force of 1 Newton may be written as 1 kilogram. Here's this minus 1 here. Remember we said the minus means per. So this is saying 1 kilogram per meter per second. That's wrong because Newton's second law tells us that F equals ma. And if you were to write the units for that, force is measured in newtons, as we've seen. Okay, that's going to be equal to mass, SI units for that, kilograms, times acceleration, which is meters per second squared. Okay, remember the more conventional way of writing it, which is like this. So that minus means per second squared, so this is the better way of writing it. Okay, so it's kilograms, so I'll get rid of all that first. So it's kilogram meters per second squared. Okay, how you can interpret that is if a 1 Newton force just means that a 1 Newton force can accelerate a 1 kilogram mass by 1 meter per second squared. That's how you can interpret these units. Or if it was a 10 Newton force, it could accelerate an object of mass 10 kilograms by 1 meter per second squared. You can also say that the other way around. So if it's a 10 Newton force, it could accelerate a 1 kilogram object by 10 meters per second squared. Okay, so that's kind of what that means. The last one, okay, so 1 gigawatt is 10 times bigger than a megawatt. The reason why that's wrong is because 1 gigawatt, if you were to write that in standard form, is 10 to the 9. Whereas a megawatt, which is a mega means a million, will be 10 to the 6. So the difference between the two is 10 to the 3. So that's 1,000, 10 to the 3. That's what 10 to the 3 means. It's one with 3 zeros on the end. So a gigawatt isn't 10 times bigger than a megawatt, it's 1,000 times bigger. So you just write 1,000 in there. Okay, moving on to the part B. So figure 1.1 shows the apparatus used to determine the density of glass. The glass test tube has a mass of 1.6 times 10 to the minus 2 kilograms. The measuring cylinder is partly filled with water. The test tube is gently pushed into the water until it's fully submerged as shown in figure 1.2. The level of the water inside the measuring cylinder increases from 75 to 82 cubic centimeters. It says calculate the density of the test tube in kilograms. See this minus, so it's kilograms per cubic meter. That means if we need these units in our answer, we must put those units into our calculation. So we must put in kilograms and we must put in cubic meters. Okay, let's start off by using the equation for density. And density is given the Greek letter rho, and it's mass divided by volume. Okay, so the mass we've already got, and it's in the correct units of kilograms, so we don't have to worry about that. Now we need to work out the volume, and let's sort of explain how this apparatus works first. If you push an object into a liquid like water, okay, in order for that object to exist in the water, there has to be water that moves out the way, and we call that displaced. So you put an object in the water, water's displaced so that object can exist in the water. Now the amount of water that's displaced is exactly equal to the volume of the object you put in there, and that can be really useful because if you have a very irregularly shaped object like this, okay, you want to know the volume of that object. It's very easy with this method because all you do is you just put this object in the water. In order for that object to exist inside the water, a volume of water needs to be displaced, which will be exactly equal to the volume of the object. Therefore, if you know the original volume of the water, and then you know the volume afterwards, because it's obviously going to go up, then the amount that's gone up by is exactly equal to the volume of the object. Okay. So going by that, we know that therefore 82, which is the volume afterwards, minus 75, which equals 7 cubic centimeters, that's going to be the volume of the glass that makes up this beaker. So that's all this glass around here. Okay, now the problem we have is this answer must be in cubic meters. We've got cubic centimeters, so to get from cubic centimeters to cubic meters, you divide, well, to get from centimeters to meters, you divide by 100. To get from centimeters cubed to meters cubed, you therefore divide by 100 cubed. Okay, if you do that, that will be 7 times 10 to the minus 6 cubic meters. The other way around you can do this is 100 cubed. Okay, if I just go back one step. Okay, 7 centimeters cubed. 100 cubed is a million, which is 10 to the 6. So you can also divide by, you can divide by 10 to the 6. You could just, if you remember that, that can be a useful thing to remember. Dividing by 10 to the 6 is the same as multiplying by 10 to the minus 6. So you could also write it this way. You could also put times 10 to the minus 6. Okay, either way around is fine. I'll just go with the method I used before, which is 7 times 10 to the minus 6 cubic meters. Okay, so now we've got our volume in the right units and the mass, which we already had, so we can now plug these into our equation. So 1.6 times 10 to the minus 2. I'll just write the units as you go along, because then it will, you make sure you're putting the correct units in. Divided by the volume, which is 7 times 10 to the minus 6 cubic meters. So we've got an answer now. If you plug that into your calculator, you'll get 2.3 times 10 to the 3 kilograms per cubic meter. Remember that minus sign, you must put that. That means per cubic meter. And again, like I said before, that's the same as, you could just put that and that's fine, because that's per, that's what forward slash means, per cubic meter, but it is more conventional in physics to write it like that. Okay, so 2.3 times 10 to the 3. 10 to the 3 is 1,000. So that's 2.3 thousand. So that's what that's trying to say is that in one, if you take 1 cubic meter, the cubic meter is just a meter by meter by meter. Okay, it's just essentially constructing a cube out of meter sticks. If you take a cubic meter of glass, there'll be a mass of, that will contain a mass of 2.3 thousand kilograms. That's how you interpret what that means. Okay, so that's the answer, 2.3 times 10 to the 3. I'm going to stop this video here. I'm going to continue part 2, which will just follow on to question 2.